Quadratic polynomial can be written as fx equal to ax square plus bx plus c, where coefficients a, b, c are real numbers and a is not equal to 0. The graph of the quadratic polynomial is parabolic. It may be upward opening for a greater than 0. A is the coefficient of x square, and it is downward opening if a is less than 0. A greater than 0 means a is positive, and a less than 0 means a is negative. Now we consider two cases that graph of the quadratic polynomial intersect with x-axis and with y-axis. So first we consider intersection with x-axis. Intersection with x-axis implies that y equal to 0. For this, the equation will be quadratic equation. It will be ax square plus bx plus c equal to 0, and roots will be x equal to minus b plus minus square root of b square minus 4ac by 2a. This b square minus 4ac is discriminant, so we can write as minus b plus minus square root of capital D by 2a, where d is b square minus 4ac, that is the discriminant. Now we consider first case that a is greater than 0. It is the parabola with upward opening. A greater than 0 refers the positive value of a. So there are three subcases. Number one, that discriminant d is greater than 0. It means two distinct roots. That means the graph cuts the x-axis at two different points, and the shape can be drawn as this is the x-axis, and the parabola will cut at 2 points alpha and beta. Alpha and beta are the roots. Second case is d equal to 0. This gives two repeated roots, and this graph touches the x-axis at a point, and this point refers the common point, that is two roots are repeated roots. Third is d is less than 0. In this case, no real roots. That means this graph does not intersect or touch with the x-axis, or we can say it is above the x-axis. So these are the three cases when a is greater than 0. Similarly, there are the three cases when a is less than 0, that is a is negative, graph is downward opening, and three cases are again d is greater than 0, second is d is equal to 0, and third is d is less than 0. If d is greater than 0, again two distinct roots, and shape of the graph is downward opening and cutting the x-axis at 2 points. These 2 points are the roots of the quadratic equation alpha and beta, and this alpha and beta are given by minus b plus minus square root of d by 2a. When d equal to 0, then it is repeated roots, and graph will touch the x-axis at a point. This point is having the repeated roots alpha and beta, and roots will be equal to, because discriminant is 0, so roots will be minus b by 2a. Third is d less than 0. It refers that no real root. That means graph does not intersect the x-axis, and this is completely below the x-axis, and we can say roots are non-real roots, or these are the imaginary roots. Next, we have to find the point of intersection with the y-axis. The quadratic polynomial is fx equal to ax square plus bx plus c. For point of intersection with y-axis, we have to put the x equal to 0. So fx, which is the y coordinate, will be equal to c. So point of intersection will be 0 and c. Now we have to find the vertex of the parabola and minimum and maximum value of the quadratic polynomial. The quadratic polynomial is ax square plus bx plus c, and the roots of the quadratic equation will be alpha beta. This will be equal to minus b plus minus square root of d by 2a, where d is discriminant having the value b square minus 4ac. For a greater than 0, that is coefficient of x square is positive, parabola is upward opening, and the v is the vertex of parabola, it will shows the minimum value of the quadratic polynomial. While the parabola extend up to infinity in positive y direction, so we will say that maximum value is not defined. Similarly, for a less than 0, that is coefficient of x square is negative, parabola is downward opening, vertex v shows the maximum value of the quadratic polynomial, and it extends up to minus infinity, so minimum value will be not defined. Now we have to find the vertex coordinates. Because roots alpha and beta are minus b plus minus square root of d by 2a, so vertex will lie between these two roots, that is, it is a midpoint. So we will say that x coordinate of the vertex will be alpha plus beta by 2, that is equal to minus b by 2a. And to find the y coordinate, that is fv, it will be equal to, we will substitute the value of xv in the quadratic polynomial. We will have a into minus b by 2a whole square plus b into minus b by 2a plus c. It will give b square by 4a minus b square by 2a plus c. It will be equal to, taking the LCM, it is 4a, and numerator will have b square minus 2b square plus 4ac. So it will be equal to minus b square plus 4ac by 4a. Taking minus common, we will have minus of b square minus 4ac by 4a, and that will be equal to minus d by 4a, because b square minus 4ac is the discriminant of the quadratic polynomial. So the coordinate of the vertex will be written as xv and yv, and that will be equal to minus b by 2a and minus d by 4a. And this is an important coordinate which we have to remember. Next, we have to find the sign of the quadratic polynomial, which is given by fx equal to ax square plus bx plus c, where a is not equal to 0. We have two cases in terms of parameter a. A is the coefficient of x square. This a may be greater than 0. It means parabola is upward opening, or a is less than 0, that is a is negative, parabola will be downward opening. And in terms of discriminant d, we have three cases. Either d is greater than 0, which says distinct roots, and d equal to 0, it says repeated roots, and d is less than 0, it says no real roots. Distinct root says that parabola cuts x-axis at two distinct points. Repeated root says that parabola touches the x-axis and it will be a single point. And no real roots means, that is d is less than 0, parabola do not touch or cut x-axis. So as a whole, we have 6 cases. First is, if a is greater than 0, d is greater than 0. Second is, a is greater than 0, d equal to 0. Third is, a is greater than 0 and d is less than 0. Fourth case is, a is less than 0, d is greater than 0. Fifth case is, a is less than 0, d equal to 0. And sixth case is, a is less than 0 and d is also less than 0. If we draw graphically, a greater than 0 and d greater than 0 refers that parabola is upward opening and cutting the x-axis at the 2 points. Similarly, a greater than 0 and d equal to 0 refers that the parabola is upward opening and touches the x-axis at a single point. A greater than 0, D less than 0 refers that parabola is upward opening and does not cut the x-axis. That means it is above the x-axis. Fourth case is A less than 0 means downward opening and D greater than 0 means cut distinct points. So we will have the x-axis graph is downward opening and cutting the x-axis at the two distinct points. A less than 0, that means parabola is downward opening, and D equal to 0 means it touches the x-axis at a single point. And last one is A less than 0, D less than 0. That means graph is downward opening and does not touch the x-axis or does not cut the x-axis. Now we can find the sign of the quadratic polynomial for all these 6 cases. In first case, the graph cuts the x-axis at 2 points, so roots are alpha and beta. In second case, root is alpha. In fourth case, again, roots are alpha, beta. And in fifth case, it is say alpha. So function fx will be greater than or equal to 0. That means it may be a positive or 0 value if x belongs to R minus excluding the value from alpha to beta. And fx is less than 0, that means negative for the value of x belonging to alpha and beta. Here alpha and beta are excluded. In second case, graph touches the x-axis, so we can write that fx is greater than or equal to 0 for x belonging to R. In third case, we can write that fx is always positive for all values of x belonging to set of real numbers. In fourth case, fx is less than 0 or equal to 0 if x belongs to set of real numbers minus alpha beta, and fx is greater than 0 if x belongs to the value ranging from alpha to beta excluding alpha beta. In fifth case, we can say that fx is less than or equal to 0 for all of the value of x belonging to the set of real numbers, and in sixth case, fx is always less than 0, that means negative if x belongs to the set of real numbers.